This is 13.6, problem 25. So what you're given is two equations. You're given x plus y equals 3. That's one equation. You're given x minus y equals negative 1. That's the second equation. And what you have to do is you have to solve the equations both algebraically and graphically. So two lines, they're both lines, you can tell that because these are lines in standard form. So they either intersect or they're parallel. So let's try to solve this and we'll see if they intersect, okay? So I notice here that I can add these two equations together. Because, here I have a y and here I have a negative y. So when I add the two equations together, the y's go out. And remember, we want to either add or subtract the equations. We can multiply them by a constant, either one of them, so that we get one variable in one equation. Then we can solve it. So I notice that the y, here I have a plus y, here I have a minus y. If I add these two equations, the y's will go away. So here I have x plus x, that gives me 2x. 3 plus a negative 1 gives me 2, so that x is equal to minus 1. So that is the x-coordinate of the point of intersection right there. You can see it here. All right, and then now I have to solve for y. So I'm taking this first equation, x plus y equals 3, and I'm substituting in for x equals 1. So I get 1 plus y equals 3, and so y is 2. So the point of intersection of the two lines is 1, 2. All right, now what I have to do is so here's my algebraic solution. The point of intersection of the two lines is 1, 2. Now I have to graph the two lines, and I will see graphically what the solution is. So taking this first equation, x plus y equals 3, this is in standard form so that I can see what the x and the y-intercept are pretty easily. Remember, with the x-intercept, y is always 0. With the y-intercept, x is 0. Okay, so when y is 0 here, I get that x is equal to 3. And then when x is 0, I get that y is equal to 3. So this first equation, the x-intercept here is 3, 0, and the y-intercept is 0, 3. So when I connect the dots here, I get this line. Now you'll notice that this point is the x-intercept, y-intercept, and this is the point of intersection. Remember, that's what it means to be a point of intersection, right? All three of these points are on the same line. Okay, now taking this second equation, x minus y equals negative 1. I'm going to try to focus this a little bit. I don't know if that made that any better. X minus y equals negative 1. When y is 0, you can see that the x-intercept is negative 1. Or the x-coordinate of the intercept is negative 1. When x is 0, you can see that the y-coordinate of the intercept is 1. So I'm going to plot this, negative 1, 0. There's my x-intercept for my second line, and 0, 1, there's my y-intercept for my second line, and it too goes through this point of intersection. So you can see just graphically that this point is 1, 2. So we have it algebraically, there's the point of intersection, and we can see it graphically as well. Okay, that's the end of 25. 27 is exactly the same kind of problem here, and so let's look at this one now. All right. Okay, so again we have the two equations. We have x plus 2y equals 10 and 3x minus 2y equals 6. Trying to get it down to one equation, one variable, in order to solve algebraically the point of intersection of these two lines. I know they're lines because I recognize that they're in standard form. So I notice again here that my y's go out just by adding the two equations together. So x plus 3x is 4x. 2y minus 2y plus a negative 2y is no y. And then 10 plus 6 is 16, so x is equal to 4. So that's the x-coordinate. 4 is the x-coordinate of the point of intersection. Solving for y, I'm going to take this first equation, x plus 2y equals 10, substitute in a 4 for x. I get 4 plus 2y equals 10. 2y is going to equal to 6 because I subtract 4 from both sides there, and y equals 3. So my point of intersection here is 4, 3, and here it is on the graph. Now, I just have to graph the two equations. The first one, x plus 2y equals 10. The y coordinate of the intercept is 0, so I get that x is equal to 10. all right? And then the x-coordinate is 0, so I get 2y equals 10, so y is equal to 5. So graphing this guy, 10, 0, 0, 5, draw the line, goes through the point of intersection as well. Graph this second equation here, 3x plus 2y equals 6. When figuring out the x-intercept, set y equal to 0. Okay, so you can see I have 3x. Whoa, I'm covering that up here. 3x equals 6, so x is equal to 2. And then setting x equal to 0, I have negative 2y equals 6, so y is equal to negative 3. So with this second point, when I graph this guy, I get 2, 0. There is the x-intercept, 0, negative 3. There's the y-intercept, and play dot to dot. You'll notice again that this line goes through this point of intersection. You can see that from the graph that it's the 0.43. So there is 27. That's done. Now we have one more problem to go over, and on this one, what we have to do is they give us two lines. 6x plus 3y equals 10, and this other line, y equals minus 2x plus 5. What we need to do is find the slope, notice something important about the slope, and then solve the equations graphically. Okay? So this first one, in order to find the slope, I got to change it to slope-intercept form. So I bring the x, I'm going to subtract 6x from both sides. So I get 3y equals minus 6x plus 10. You know, when I subtract 6x from both sides, I'm trying to get it into the slope-intercept form, y equals mx plus b. Okay, so I want to have my x's first. So I have 3y equals minus 6x plus 10. That's what I start with. You know, got to just solve for y, not 3y. So divide everything by 3, both sides of the equation. So divide this term by 3, divide this term by 3. I get y is equal to minus 2 over 1 x plus 10 thirds. So you can see from this equation here, here's my slope. It's minus 2 over 1, negative 2 over 1. Okay, now on this second one, this is already in slope-intercept form. And so slope-intercept form, y equals mx plus b, I want to look at the coefficient of the x term, which is negative 2, so my slope is negative 2 over 1. So what you notice is that these two slopes are the same, so that must mean the lines are parallel. What I want to do now is solve the equations algebraically and see what happens. We're going to see that we get some gibberish, and that's going to be kind of interesting. Okay, so I take my first equation, 6x plus 3y equals 10. And let's see, what's my second equation? Oh, I have a mistake here. Alrighty. Turning this over, I'm going to do it on the back side here. Okay, we have 6x plus 3y equals 10. That was the first equation. And then the second equation was y equals minus 2x plus 5. Y equals minus 2x plus 5. All right, so this second equation, it would really help if I put this into standard form so that I could solve them simultaneously here. So let me bring the 2x back over to this side. Okay, so let me rewrite both of them. I have 6x plus 3y equals 10. And the second equation is 2x plus y equals 5. So here's my system. All right. Now, interesting. What am I going to do? I have to solve somehow. I've got to figure out what I can do to the second equation to get rid of, say, a y or an x. So let me multiply both sides of this by 3. Okay. And so I have 6x plus 3y equals 15 here. And I still have my same first equation, 6x plus 3y equals 10. And let's see, when I subtract these guys, what do I get? 6x minus 6x, that's 0. And here I have 3y minus 3y, that's 0. And 10 plus 15, 10 minus 15 is negative 5. So I get 0 equals negative 5, which is nuts. This is nonsense. When you get nonsense for an answer when you're solving simultaneous equations, you know that the lines do not intersect. They're parallel. So this is the key here. All right, that is the end, folks. We will call it quits now. Okay.